So we're going to look at, we're going to focus on, we're still on quadratics here, and there are three forms. So in the title we're going to say standard and or vertex form, two-factored form. So we have our three styles here. There's a standard form, which is common, the vertex form, and the factor form. And we talked before, standard gives you the y-intercept, factor form gives you the x-intercept, and vertex lets you know where the vertex of a quadratic is. So they all have their features that are helpful, but we want to know how to move from one to the other. So we have two versions of something here. First one here is we have a vertex form. So we're just going to kind of highlight that. There we go. So this is our vertex form in blue, and this one here is our standard form. And just to prove that they're the exact same equation, we're just going to Desmos, and we put them in here, and you can see that when I turn the red one off, the blue one goes there, the red one goes right over top. So these are the exact same, okay? So what we're going to work on is we're going to talk about how to move, whether we have the factored form. I do that every time. Whether we have the factor form, how to move it to factored form, and if we have the vertex form, how to move it to factored form. Okay, so we're going to start with the standard form because there are some common ways. Essentially, what they're going to tell you is you factor, okay? But there's lots of different ways of factoring. There's something called like a difference of squares. That's for specific ones. There's like factoring by decomposition. There's perfect square trinomials, and blah, blah, blah. And all of those different factoring styles are for pretty specific quadratics. Like, they have to be built a certain way. The one that always works is called, I'm going to call it the Quadratic Formula. Have you ever dealt with this before? Yeah. So the Quadratic Formula, even if it's in any of these other forms where factoring would be faster, sometimes it's just hard to recognize if something can be factored using difference of squares, we do decomposition. Quadratic formula always works. Doesn't matter what you do. So it kind of makes sense to actually really focus on making sure you can use the quadratic formula. Quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to go to another page and talk about that. But those a, b's, and c's are all related to our standard form because we know we can break our standard form. We know we can break our standard form into something that kind of looks like this. ax squared plus bx. I'm just going to do it in red because we're kind of with that letter for standard, plus c. And that's what those letters pertain to. There's a b there, an a, a c, an A, and a B. And we would just replace those numbers in this formula, okay? We'll talk about how to do vertex to factored after. It's actually kind of a form of isolation. But let's move to a new page and work with this form. So I'm going to have to remember what we got there for a standard form. But I think it was y equals negative 0.2x squared minus 1.48x minus 2.438. So, really hard to do factoring with. If they talk about like finding two numbers that multiply to the outside, add to the, multiply to c, add to b, regular decimals, there's way too many options for this. So we use quadratic formula. So, this is our a value. I'm going to change the colors now since we're isolating. Here's our b value, and here's our c value, okay? We'll just write on top just so, again, that you're used to seeing it. And that would be A, this would be B, and this would be C. In our quadratic formula, we're looking for x. They're saying x equals. In other words, the x-intercept's equal because we're kind of setting this equal to 0. Okay, so we're saying x is equal to negative b, and then we'll talk about the plus or minus after, why that's the case. The square root of b squared minus 4a c, and then the entire thing is divided by the number 2 multiplied by whatever the a value is. Okay, so we're going to go about solving this. So x equals negative, well, our b value is actually a negative value, negative 1.48. So we have them, think of it like negative 1 times that, okay? So we're just going to plug everything in to start. Again, we have negative 1.48. This time it will be squared, minus 4 times. our A value is negative 0.2, and our C value is negative 2.438. Do you have a calculator handy?
Yeah.
Okay, so I'm going to need it after. I'm not going to be able to do these in my head. 2... Let's see who that is. Okay, little dog interruption, but we're back here. So we're going to start just calculating. This is all just carrying out like bed mass now. As long as we can carry out bed mass, we're going to be able to do this each time. The only part that's going to get tricky is when we start to deal with this plus or minus, but I'll talk about that when we get there. So x is equal to negative times a negative is going to be a positive. So we have positive 1.48 plus or minus the root of. Now, this part's going to be a little trickier, and actually, do you have your calculator handy?
Yeah.
Okay, why don't you get your calculator handy? Negative 1.48 squared.
Oh.
Yeah, or times negative 1.48. You can just do that again. Times negative 1.48. And maybe I could bring it up in a calculator on here too. I have my decimals. Oh, I do. How very convenient. Let's bring up both at the same time. I want this one on this side. Oh, it always goes to that side. There we go. Okay, I'm going to try to do it with you here. What did you get as a value for that?
Oh, I just...
Negative 1.48
2...
squared. Did you get positive? It should be positive.
Yeah. 2.1...
1904. So if you notice on my calculator, it went negative, and that's just because I didn't put brackets around it. The calculator interpreted it as 1.48 squared with a negative times like negative 1. So the calculator kind of gives us wrong value. So we've got to make sure we remember our rules. Negative times a negative is going to be a positive. On this one here, we have negative 4. So we'll do another one here. Negative 4 times negative 0.2 times negative 2.438, is it? I believe so, yeah. So 3 negatives, that's going to be a negative value, so we're going to be subtracting. And I got 1.9504. Wonderful. All of that is over, and I did forget to write the A value down here. 2. All of this is going to be 2 times that, which is actually just going to be negative 0.4. That is one I can do in my head. Great. We still got to deal with the square root, which I won't be able to do off the top of my head, so let's try it here. We have I'm going to do next line. 2.1904 subtract 1.9504. Ooh, that's not a 0. 04. Great. We'll just go right into that. 1.48 plus or minus the root of 0.24. Okay. Now this is where the square root becomes important. I'll go to the next line. Square root of 0.24. So it gives us a value. The thing about square roots is there's actually 2 answers to them. And the reason to that is I'll quickly do it. Imagine we're doing the square root of 25. They give us the value of 5, okay? But if I do 5 times 5, yeah, that's 25. But I can also do negative 5 times negative 5. And I get 25. Both of those are the correct answers. So anytime you square root something, there's actually 2 answers to it. That's what the plus and minus is telling you to do. It's reminding you that, hey, you got to get 2 answers when you do the square root of this, okay? So I did the square root, and it was 0.489. It's a long one. I'm just going to go to, let's call it 0.4899. I don't want to round up too far there. So we're going to get x is equal to, so I might have to shrink this. Oh, good. There we go. So we're going to get with 2. We're going to call it x number 1 is equal to 1.48 plus 0.4899, still all over negative 0.4. And then x number 2, because there's going to be 2 x-intercepts, that's also why we should get 2 answers, is 1.48 minus 0.4899 over 0.14. So now we're working with 2 different answers, which is fine. You can have 2 solutions to something in math, and sometimes you get millions of solutions to things in math. Now we're just going to work out the fine details of this. So we're going to do the numerator there. 1.48 plus 2.4899 becomes 1.9699, still over negative 4. I'm going to just keep going with that one. Take that answer from before and divide it by negative 0.4. And we have an answer. x1 is equal to negative 4.92475. That's very, very accurate. Great. We got one. Let's go to the other answer here. That's why calculators are quite handy, right? All of these decimals will be tedious to deal with. So we're doing 1.48 minus 0.4899. Great. We're going to take that answer, divide it by negative 0.4, and we get, so I did that all in the calculator instead of writing it out, negative 2.47525. Okay. Let's push our calculator away for a moment. And what I really want to do is I want to bring up Desmos, because we technically can check this out really easily on Desmos. Give us a little extra size. If I take a look here, negative 2.475, yeah, that was one of our x-intercepts. And the other one was negative 4.9. They got 2.5, we got 2.475. We were more accurate than the calculator, but great. That's exactly what we've done now. So the question is, confirmed with Desmos, the question is, how do I put this in the factor form? If you recall factor form, I think I was doing it in green. It's written like this: y is equal to an a value, x minus r, x minus s, okay? Think of this x2 here, how big? Oh, on the right one. Feels like my writing got a lot thicker. X2 and x1, those are actually the r and the s. Think of this as r or s. And it doesn't matter which one we put where. Okay, so we can plug those directly in for these values here. The one thing that we didn't solve when we did this was a, but do you remember the trick with a?
No.
No? The trick with a is the a value is the exact same in Vertex, standard, and factored form. We already have the a value. It's right there. So when I go to write this as our answer, y is equal to, I want to make this smaller. It feels like that's too large. Negative 0.2, that's our a value because we had it from here before, okay? I know I'm kind of running out of room. X minus, now this is important, we subtract, we're going to subtract the negative value, so I'm kind of running out of room. Negative 4 point, we're just going to say 925, okay, just so we have some room. I'm going to stack this one below and then make some room in a second. X minus again, negative 2 point, I'm going to say 475, and we'll just leave it at that, okay? And what I'll do is I'll shrink the page a little again, and then we'll write it out. Y is equal to negative 0.2. Now, remember this is a negative of a negative. Do you know what that equates to in terms of an operator? Exactly. So it's going to be x plus 4.925, we said. X, and this is a negative of a negative again, plus 2.475. So now we have our factored form, and if we do go to put this into Desmos, we should find that we get the exact same thing. Y equals negative 0.2 bracket x plus 4.925 and bracket other bracket x plus 2.475 and overlaps perfectly. So we've got it. But again, we did a lot of work there. That was actually only one way of doing it. That's assuming we have the standard form. You know what I'll do? I'll move to a second video, and because if you recall when we started, we still haven't done the vertex form. I'll do a whole nother video for the vertex form, okay? Whoops, that's not what I want to push.